Electrodes can be defined as any substance that is a good conductor of electricity and normally being connected to the non-metallic parts of a circuit. So, two common terms when studying electrodes are the anode and cathode. Anode is known when the current enters the electrolyte during oxidation reaction. Cathode is a result that occurs by a reduction reaction that takes place in a reaction mixture, in which the current leaves that electrode. The use of electrodes is to generate electrical current in order as well as pass it through non-metal objects as to alter them in various ways. Conductivity is also measured using electrodes. Three main electrodes which are working electrode, counter electrode and reference electrode. Working electrode is an electrode on which a reaction of interest is occurring. It is connected with CE. Counter electrode is used to close the current circuit. It is made of inert material such as gold or graphite. Reference electrodes have a stable and well-known electrode potential. Initially, the reference electrode is used to measure the potential in the solution. The Re should pass some of the desirable characteristics so that it will function well. It must be easy to construct or prepare and also should develop potential which are reproducible even if small currents are passed. As we can see here, these are the most common typical type of reference electrode being used. The first one is copper-copper sulfate reference electrode, followed by saturated calomel electrode and silver-silver chloride electrode. Basically, the determination of a reference electrode depends on the electrolyte of the solution. To be more clear, let us have a look for an example. Let's say if we have a sodium chloride solution. In order for us to determine the type of reference electrode, we must consider the presence of ions in the electrolyte. In this case, it is a chloride ion. So, the most preferable electrode for this solution is silver-silver chloride. Counter electrode is used for measurement of current, used to close the current circuit in the electrochemical cell and also work as a cathode when the We work as anode or vice versa. Counter electrode usually made of inert material as platinum, gold, carbon, and nickel. Simply we don't want the counter electrode to interfere with our reaction under consideration. The only criteria for the counter electrode is that it should allow fast electron transfer so that it does not limit the rate of the reaction taking place at the working electrode. The reference electrode acts as a reference point for the redox couple. The current resulting from the electrochemical reaction is amplified and, when plotted as a function of time, appears as a peak on the recording device. Selection of working electrode. Firstly, the material should exhibit favorable redox behavior with the analyte, ideally fast, reproducible electron transfer without electrode fouling. Secondly, the potential window over which the electrode performs in a given electrolyte solution should be as wide as possible to allow for the greatest degree of analyte characterization.